Okay. The problem given is find RHS of this 4 by 4 determinant. You multiply first row by A, second row by B, third row by C, fourth row by D. You get this determinant, and now you can take out A common from first, B common from second, C common from third, D common from fourth. So practically it is one and the same determinant. This is 1 upon 1, ABCD upon ABCD is A square plus 1, A square, A square, A square, B square, B square, B square, C square, C square, C square, D square, D square, D square, D square plus 1, C square plus 1, B square plus 1. Okay, this kind of determinant we are left with. Now, uh, again we have to check what if it was A square plus 1, A square, B square, B square plus 1. This is easy to deal with. A square, B square, B square. So this you can consider this as 0 plus 0. So it gets separated in 4 determinants plus A square, B square, 0, 1 plus 1, 0, A square, B square plus 1, 0, 0, 1. You will observe that first determinant is a square b square minus a square b square is 0. Second determinant is a square. Third determinant is b square. Fourth determinant is 1. So whenever you happen to have something like this, you are getting this. Maybe you can directly conclude or try 4 by 4, 3 by 3 or something like that. And we can, is there any other way by which we can make it so this is going to be equal to 1 plus a square plus b square plus c square plus d square. I mean, I'm just extrapolating from here to here, but if you have better method for dealing with this determinant, you can tell me.
सर तर मी आधी 1 बाय एबीसीडी कॉमन काढण्यापेक्षा एबीसीडी कॉमन काढला आणि मग त्याच्यानंतर ते झिरोज आणले सबट्रॅक्ट
C3 ऍड करून C2 सबट्रॅक्ट करायचं.
C1 मध्ये काय करायचं?
C3 ऍड करून C2 सबट्रॅक्ट करायचं.
बर,
मग 2 कॉमन काढायचं. मग आपल्याला फर्स्ट कॉलम एबीसी मिळतो आणि खालचे दोन तसेच राहतात. आणि मग आता आपल्याला एबीसी मिळाल्यानंतर आपण ते C3 मधनं C1 सबट्रॅक्ट करू शकतो. मग आपल्याला सगळ्या खालची रो CAB मिळते आणि मग ती आपण C2 मधनं C3 सबट्रॅक्ट केली आता मिळालेली नवीन, तर मग आपल्याला हवा तो मिळतो.
okay. So let me check. What he is saying is for row number 1 minus row number 2 minus row number 3. असंच म्हणतो.
शेवटची ऍड करायची.
1 minus 2 plus 3 म्हणजे काय होईल? 2a 2a येणार.
हो सर.
2a 2b 2c b plus c c plus a plus b c plus a plus b b plus c. गुड. 2 कॉमन काढला त्यामुळे आपल्याकडे एबीसी मिळाला. तर तो ए तिसऱ्यातनं सबट्रॅक्ट करायचा का? आता काय करूया?
तर आता ती पहिली रो जी मिळाली आहे एबीसी ती आपण तिसऱ्यातनं सबट्रॅक्ट केली तर खाली सी बी
सी ए बी राहणार.
सी ए बी मिळतो.
गुड.
आणि मग दुसऱ्यामधनं तिसरी सबट्रॅक्ट करायची.
दुसऱ्यामधनं तिसरी. व्हेरी गुड. व्हेरी गुड. दिस इज व्हेरी गुड. नेक्स्ट प्रॉब्लेम.
सर अजून एक
हा, अजून एक काय दाखवू नको, सांग ना.
कॅमेरा.
हा, अरे सांग म्हणजे लोकांना उपयोगी पडेल.
हो सर दाखवलाय कॅमेरा.
कॅमेऱ्यात दाखवलंय. थांब जरा, मी बोलायला लागलो की माझं दिसतं. स्पॉटलाइट फॉर एव्हरीवन. स्टॉप शेअर. स्पॉटलाइट फॉर एव्हरीवन. रिमूव्ह स्पॉटलाइट. स्पॉटलाइट. हा, क्वेश्चन मार्क विच इज ट्रू. अच्छा, तू क्वेश्चन विचारतोयस की सोल्युशन दाखवतोयस?
इफ अँड ओनली वापरून प्रूव्ह
करता येईल का? बरं. Question 4. Factorize this determinant. Correct. Okay. Reciprocal determinant or adjoint determinant definition. If you have a determinant, then corresponding determinant of cofactors is called reciprocal determinant. Cofactors are called inverse element. Theorem is, if delta is a determinant of order n, then determinant delta dash is delta raised to n minus 1. Now we have not discussed multiplication of two determinants yet. So two determinants can be multiplied like matrix multiplication, row into column, or you can do it by row into row. That means you can do it by column into column also. So we have demonstrated here, if we have taken 2 by 2 determinants and row into row and column into column multiplication turns out to be exactly same. So using this property of multiplication, you can prove this theorem very quickly. Proof, consider delta into delta dash, row into row multiplication. So A11 gets multiplied with capital A11, that produces determinant delta. A11 getting multiplied with capital A12 will be 0 because we have seen two columns are going to be same. So all other triangular entries, the principal diagonal and below principal diagonal are going to be 0, and therefore determine the product of these two is going to be delta raised to n, only principal diagonal, correct? And therefore delta dash is equal to delta raised to n minus 1. This is theory part. Theorem. A skew symmetric determinant of odd order vanishes. That means equal to 0. बघा जरा प्रूव्ह करायचा प्रयत्न करा. ऑड ऑर्डरला महत्व आहे. इवन ऑर्डरचं थिअरम लिहून देणार, आउट ऑफ स्कोप प्रूफ. If A is skew symmetric, then A transpose is equal to opposite of A. This is as far as matrix is concerned. Now if you take determinants, determinant of A transpose is equal to determinant of opposite of A, which is minus 1 raised to n. You can take out minus 1 common from all n columns, minus 1 raised to n, determinant of A. Now if n is odd and determinant of A transpose is A, determinant of A. If n is odd, determinant of A is equal to opposite of determinant of A. Implies determinant of A is equal to 0. Next, a skew symmetric determinant of even order. Is a perfect square. Proof beyond our scope. Maybe you can cross check. We will cross check. Skew symmetric determinant of even order. Easy to cross check 2 by 2. 0, 0, 5, minus 5, 5. Of course, it is going to be 5 square. Difficult to prove at this stage. Okay, next problem. How much money? We have sufficient time today, no problem. One more lecture on determinants and determinant is over. Find value of. Why am I stretching? I should make it little more percentage 40 up. Okay. Find the value of L1, M1, N1, L2, M2, N2, L3, M3, N3, if L1 square plus M1 square plus N1 square is equal to 1 and L1 L2 plus M1 M2 plus N1 N2 is equal to 0 and similar, equal to 0. That means L1 L3 plus M1 M3 plus N1 N3 is equal to. Then what am I trying to do? चला करा बघूया. So sigma 2 type of identities are 0 and S1 is equal to 1. Find the value of this determinant. That is a good question. Consider delta into delta. L1 M1 N1, L2 M2 N2, L3 M3 N3 into L1 M1 N1, L2 M2 N2, L3 M3 N3. And if you do this row into row, you are going to get L1 square plus M1 square plus N1 square, L2 square. Diagonal elements will be 1, 1, 1. Together L1 L2 plus M1 M2 plus N1 N2. Every other element is 0, 0, 0, 0, which is equal to 1. Therefore, delta is equal to plus or minus. So, see, multiplying two determinants to get one determinant, easy. Given one determinant, to factorize into two determinants, difficult. This is always going to happen with you. Factorization is always difficult. Multiplication is always easy. So now let us see if you can see factorization. Show that. Factorize 1 a square plus b square plus c square. Now I mean this is very easy. Anyway, having done the first, abc plus ca plus ab, bc plus ca plus ab, a square plus b square plus c square, a square plus b square plus c square, bc plus ca plus ab, bc plus ca plus ab, bc plus ca plus ab, bc plus ca plus ab. Now this is actually going to be very easy for you, but just finish it. What is this? Otherwise, I mean, if we have not done this problem and if the multiplication definition is not available or not learned, then this is extremely difficult determinant. But now it is going to be very, very simple. Just do it. You can directly write it if you can see that this is a multiplication of these two determinants, a square plus b square, row into row multiplication. Or even if you consider row into column, it will be same. Row or row a square plus b square plus c square, ab plus bc plus ca, and so on. So this is a cube plus b cube plus c cube minus 3abc bracket raised to chop. Last problem. Today's last problem. Prove that ABC, BCA, CAB bracket square is equal to a square minus BC, B square minus CA, C square minus AB, C square minus AB, A square minus BC, B square minus CA, B square minus CA, C square minus AB, A square minus BC. Okay, there was correction in LHS, ABC, CAB and BCA. And once that is done, we have proved this theorem, delta raised to n minus 1 is equal to delta dash. Using that, this is delta adjoint matrix. So it is obvious that these two i's are equal. Okay.